Hello everyone, I am Rishim Manaviatel. Today's lesson we are going to talk about mass movement. In last session we had seen about weathering and different processes of physical weathering. In today's lesson I'm going to teach you different questions which have been asked which are related to mass wasting. What you have to remember here, mass wasting is also one among denudation processes. I told you that denudation processes include those processes which took place on the Earth's surface, and it includes weathering, mass wasting, soil erosions, and landslide as well. We are going to start on the question number 1, which is to differentiate between mass wasting and soil erosion. First of all, you have to understand that all of those processes are denudation processes, but the way that it occurs are different. We are going to see how it is different. When I'm talking mass wasting, I want to mean the downhill movement of weathered materials due to the influence of gravity, or the creeping or flowing or sliding of rocks and weathered materials of debris down to the slope under the influence of the gravity. And it is different from soil erosion in the ways that with soil erosion, running water or wind physically erode and transport away topsoil. However, in mass wasting, water is not always necessary because every dry rocks may slide and fall downwards from highland due to the influence of gravity. Even where water is available, it only acts as lubricant or increase on the weight of the falling of the rocks. Understand that mass wasting is different from soil erosion due to the fact that mass wasting is accelerated by the gravity of the landscape, whereas soil erosion is accelerated by running water and influence of wind. Yes, here we have a figure which shows different areas in East Africa which have been affected by mass wasting. As you can see, mass wasting is highly affected to the areas which are prone to the highlands and mountainous regions. Here you can see we have Mount Kenya, we have Mbale, Kasese, Mount Rwenzori, Muhavula Ranges, Mbeya. We have mountain Kilimanjaro here from Tanzania, Uluguru Ranges, Southern Ranges. All of those are the areas of highland in East Africa which are affected and which are highly at risk to be affected by mass wasting. Yes, we can continue to the next question after getting the understanding of mass wasting and how it is different from soil erosion. Now we are going to classify the types of mass wasting. Basically, mass wasting is divided into two. We have a slow mass wasting and rapid mass wasting. When I'm talking about rapid movement, I'm talking also about landslide. When mass wasting acts at high rate, we call it landslide. The major types of landslide include slumping, or what we call seeping, include rock slide, rock fall, and mud flows, flows and avalanches. While the major types of slow movement of land include talus cliffs, soil friction, and soil cliffs. Now we are going to see how it is different from rapid movement of the rocks to the low movement of the rocks, we are going to see the classification which include in slow movement and the classification which include in the rapid movement. Remember, rapid movement are what we call landslide. Yes, types of soil movement or slow movement include soil creeps. Soil creep occur on gentle slope with unconsolidated weathered materials. It involves slow movement of massive soils downslope under the influence of gravity, and it is usually facilitated with heavy rains. The soil gets saturated and heavy, causing slow movement downslope under the gravity. It may be detected from a titled trees or pore or blockage of river streams. When I'm talking rock creep, this involves movement of rock debris. Remember, rock debris involves all those rock fragments and rock particles which move slowly on the downslope. Such rocks may move under soil creeps. Examples can be found at Kaprochorwa and Silonko in eastern of Uganda. Soil friction, this is limited to glaciated region like the region of altitude and glaciated mountains of East Africa like Rwenzori, Kilimanjaro and Mount Kenya. It involves the slow movement of saturated gravel and weathered rocks over the frozen subsoils and rocks. During freezing, there is a less movement, but with thawing or what we call melting of snow, the gravels tend to creep for a short distances. So friction, it is prone to the or limited to glaciated regions. Here we have a figure which shows well how all of those three different types of slow movements, how it occurs. And here you can find talus creep on the figure number 1. You see how the moulders or the fragments of rocks are removed from the top of the highland and which moves down the slope. You can see soil creeps also, how the soils are moving. You can see soil friction which are limited to glaciated regions. Yes. All of these three are types of slow movement. Yes. You can see rock creep involve the slow down slope of the rock debris. You can see soil friction, limited glaciation regions, and you can see soil creep which occur on gentle slope. Remember, gentle slope is the area which are relatively flat compared to steep slope. Now we are going to see different types of mass wasting based on rapid movement and are called landslide. Yes, these can be defined as sudden and rapid movement of rocks and soil debris or material downslope under the influence of gravity. There is no way which is different from slow under the influence of gravity, where rock debris are fall slowly and whereas at the rapid movement there is a sudden rapid movement of rock debris under the influence of gravity. The major types of landslide include talus creep. When I'm talking talus creep, this is the movement of angular rocks or screes of all sizes downslope. It involves the movement of weathered materials as a mass of over moderate slopes where freeze-thaw is frequent. Freeze-thaw weathering process tears out rock particles from the surface. Such rocks move downslope under the influence of gravity, and thawing water or ice provides a lubricant. Rock fall, freeze fall or free fall of individual rocks and boulders down very steep slopes, vertical slopes at very fast speed. Example of such can be found at Mount Silongo and Mount Rwenzori. Slumping, or what we call rock slump. This is a movement of large mass of rock materials and debris on overstepped slope, or cliffs, or scarps, or roads, cutting at fast speed. It is common where massive impermeable rocks slide off the underlying soft and permeable rocks and move rapidly down slope. Rock slide. This is another type of rapid movement. Rapid movement of large masses of detached rock particles, debris rolling down at fast speed along a slippery, over-steeped slope. It is accelerated by earth movement like earthquakes and the intensity of gravity due to steepness of slope. This is common along the Pale Ranges in Tanzania and Usambara, and Butiaba escarpment in Uganda. This is a figure which shows also rock slide, rock fall, and rock slump. All of these are forms of rapid movement, of mass wasting. Mud flows. Mud flows are a movement of semi-rigid with gravels, boulders on moderate to steep slopes at fast speed. They are common in arid and semi-arid areas, as well as volcanic region of East Africa like Kigezi Highlands, Mount Kilimanjaro, and Mbale along the slopes of Mount Elgon. Also, they may be caused by combination of factors such as prolonged rain, absence of vegetation, and etc. Avalanches, these are sudden downfall of rock materials embedded in ice and snow on steep slopes. In East Africa, it is restricted to permanently snow-capped mountains of Rwenzori and Mount Kenya, also as well as Mount Kilimanjaro. Next question is to explain causes of mass wasting in East Africa. Mass wasting involves the sudden fall of rocks and soil particles down slope under the influence of gravity, and there is different causes for such instance. Firstly, we are going to talk about relief. Relief, it is the major cause of mass wasting. Relief refers to general appearance of landscape. The gradient of the slope determines the rate of downward movement. For example, very steep slope encourage rock fall due to there is a high gradient, so the rocks are at the higher risk to fall. Oversteepened scarps or cliffs and road cutting encourage rock slide, rock slump, and avalanches. Steep slope encourage rock slide, mud flows, and avalanches. Said, moderate to steep slopes encourage mud flows and tar slip. Gentle slopes encourage soil creeps, soil friction. You see, gentle slope, actually it is influenced by slow movements. Yes, the next factor or next causes of mass wasting is what we call climate. Climate, we talk about elements of climate. Heavy rainfall, available water that saturates rocks and weathered materials, making it heavy, and also lubricates the slopes, resulting into mud flow and rock slump. Ponding effect of heavy rainfall destabilizes surface layers of rocks, triggering movement of rocks and weathered materials under the influence of gravity. Temperature changes that lead to alternate freezing and thawing makes the ground slippery, and water made available increase weights leading to mud flows, tar slip, rockfall, and avalanches. The next causes is nature of rocks. Nature of rocks. Permeable water rocks. These are rocks which allows water to pass through. Absorb water, then get saturated, overloaded and lubricated, encouraging mud flows and rock slide and vice versa. Well-jointed rocks may encourage landslide in the form of rockfall, slides, and avalanches. Alternate layers of hard and soft rocks also cause landslide in the form of rock slump or rock slide. Fourth causes is nature of the soil. Heavyweight massive clay soils encourage landslide when they absorb water. The weight increase, become lubricated and are much slippery, thus leading to mud flow. Earthquakes and aftermath cause vibration that triggers off landslide like rock slump and rock avalanches. Overloading, I'm talking about those materials and particles which are accumulated to the soil or rock particles. Also, it increases the weight, which boosts the risk of mass wasting. So, overloading or accumulation of rock debris in large masses on oversteeped slope also promote landslide. Tectonic movements, I'm talking about faulting, warping, also create steep slopes, cliffs and escarpment that encourage rock slide and rock fall. Also, volcanicity involving basic lava flows down slope mixed with ash promote rock slump and mud flow. Next causes is human activities that promote landslide. When I'm talking about human activities, it's the state of human influence on the earth which triggers mass wasting. Among those human activities include construction of roads and settlement and etc. In highlands or hilly areas which leads to cliffs that encourage rock slump and rock fall, also rock landslide. Meaning and calling. Yes, meaning and calling involves the use of explosive that cause vibration that encourage on steepening and exposing slope that triggering rock slide, rock fall and mud flows. Poor agricultural methods like up and down frothing makes unconsolidated soils and weathered rocks material to move down slope in form of mud flows and rock slide, also rock fall. Deforestation, also that's another human activities that triggers to mass wasting. The deforestation along the slope, leaving the slope bar exposing it to rainwater, which encourage mud flows and rock slump. Overstocking and overgrazing. On the steep slopes, loosen the rock structure leading to slumping and mud flows. This may be due to exposure of the soil or rocks material and trampling of animals due to the bare soil. Movement of heavy vehicles, trailers, buses and trains cause vibration along road, cutting and steep slopes that encourage rock slump, rock fall, example Kabale, Kisoro Road, or Simu, Kapchorwa and Road. Heavy vehicle cause vibration that may encourage mass wasting. Next, human activities and another causes. Here I'm talking about human activities in general and how it causes mass wasting. Apart from that, we have the deforestation and removal of vegetation from steep mountain. This leads also risk to mass wasting. The role of living organisms such as burrowing animals like squirrels also loosen the soil, while stamping action of big animals like elephants and zebras cause vibration leading to mass wasting. Additional weight from materials of rainwater promotes also overloading, which leads to mud flows and rock slide. Thank you very much for watching this video. Your comment is supportive for us to improve the quality of our tutorials. I am Dushimman Viator, and before we close this session, I wish we can recap together different meaning of mass wasting, types of mass wasting and causes of mass wasting. In next video, we learn together the strategies and measures on how we can control mass wasting. So we see that mass wasting is downhill movement of weathered material due to the influence of gravity. And we see that soil erosion involves the movement of eroded soil under the influence of rainfall from one area or one region to another. We see we have a different types of mass wasting, where we have rapid movement, which is also called landslide, and we have a slow movement. Among the slow movement, we saw there is soil creep, we saw there is soil friction, and we saw also rock creep. Under the landslide, we saw different types of landslide, which include talus creep, avalanches, rock fall, and also rock slide. Different causes of mass wasting, we saw there is relief, influence of relief, steepness and gentleness. We saw climatic factors, we saw nature of rocks, we saw nature of soil types, also the role of human activities. All of those contribute to the mass wasting, particularly in East Africa. Thank you, thank you very much for watching this video. We shall meet in the next video. I really love you. Thank you.